In this video, we're going to walk through the solution to a practice problem. This problem is going to calculate the standard free energy change for a redox reaction. We're not giving anything here except the actual reaction itself, but from any redox reaction, we can extract out information about its cell potential. So we're going to use the equations, make sure I'm in the right. Yep. We're going to use the equation, the cell potential, the standard cell potential is going to be equal to that cell potential of the cathode minus the cell potential of the anode. If you prefer, you can also use the cell potential of the oxidation or reduction plus the oxidation. And then we're going to use that to calculate free energy. Using the equation, the change in standard free energy is going to be equal to the negative of the moles of our electrons in the balanced equation times our Faraday constant times our standard cell potential. So the first step is going to be getting that cell potential and determining N. So let's start with our cell potential. We have iodine that is being reduced to iodide, and we have bromide that is being oxidized to bromine. So I'll look up the two cell potentials in the standard cell potential table. And for our 2Br minus, sorry, I flipped it. Let's do it like this. Br2 plus 2 electrons will give us 2Br minus. That'll give us a reduction potential of 1.09 volts. Then we have our iodine reaction where our iodide plus 2 electrons is going to give us 2 iodide for a reduction potential that's equal to 0.54 volts. So we'll set up our equation for our cell. So remember, our cathode is always reduction and our anode is always oxidation. And so we're going to have our oxidation, which is our bromine, right? That's losing those electrons. That's oxidation. That'll be anode. This will be reduction. This will be cathode. So that cell potential is going to be equal to the cathode, the 0.54 volts, minus the positive 1.09 volts. That's going to give us a value of negative 0.55 volts for our cell potential. Now we should also take a look at N. So we have, in both of these cases, 2 electrons that are converting or being transferred, and that's for our balanced reactions matching these half reactions that we looked up in our table. So 2 bromides, or each bromine ion is going to lose 1 electron, and that's going to then be 2 electrons total for our balanced reaction. So our N value equals 2. So I'm just going to plug those into our free energy expression. So that free energy change is going to be equal to the negative of our 2 moles of electrons times our Faraday constant, which is one I can never remember off the top of my head, but it's 9.6485 coulombs per mole electron. And then our standard cell potential is that negative 0.55, and that's in joules per coulomb or volts. So when I plug this all in, I should get a value that is plus 1.1 times 10 to the 5th joules. So I'm getting a free energy value that is greater than 0. So I don't expect this to be a spontaneous reaction.